All right, let's try one more projectile game. This one ought to be fun. Let's see if we can get two projectiles to collide. So the first thing we'll need to do is try to get a second projectile in here. So I'm basically going to need to take this code and double it. So let's see how we might do that. The first thing we need to do is create two projectiles, right? So I'll need a launch speed 1, launch angle 1, and a launch speed 2, and a launch angle 2. All right, let's just make those the same for right now. Then I'm going to need to create two projectiles here. So I'll need a ball 1 and a ball 2. And what that means is I'm going to need to duplicate everything I do with ball 1, I'm going to have to do with ball 2. And let's actually update the color here. Color equals color dot blue, not glue, blue. And let's make the other one color equals color dot green, just so that we can tell them apart. So now every time I have ball do something, I need to do that with both of them. So let's have ball 1, ball 2 set their mass. 1 and 2, keep going down. Same thing here with the ball.velocity and ball.pause. So I need 1, 1, 2, 2. By the way, we have to do this all the time because what happens nearly every time you run a code is that you end up wanting to do something with it. Like you end up wanting to repeat it. And so it's a really important skill to learn that you take the code, copy paste it, and modify it so that it does a new thing, right? Let's see. I don't think we're going to be interested in all the distances on this one since we're just trying to get them to collide. Time is going to be the same, right? We want to have a single loop where we're animating both of these things. And so what we'll need to do, I can get rid of this maximum height stuff, and I can just delete all this down here. What I want to do is take a look at animating both of these. So I need to make this one, you know what, let's make this either one of them. So ball.1.pause and ball.2.pause. Cool. Now, when it comes to the animate function, I could do this one of two ways. I could either set it up where I copy and paste it within the function, but there's actually an even better way to do this, and that's to just make an argument for this function. So when you make a function, you can pass anything you want into the function as an argument or as an input. It's like when you have f of x, right? This is like the x that goes in and the f is the thing that comes out. Well, ball now is going to be the thing that comes in, and all the animation is going to be the stuff that comes out, because now what I can do is I can say animate ball 1 and animate ball 2. So let's run this really quick to see how this will work. I've got two of these things running with each other now. I need to increase the launch speeds. Actually, let's give them a little bit different launch speeds. Goodness gracious, why are these? Oh, my angle is rather shallow. So let's try this. And now my angle is rather much, so let's decrease the launch speed there. Let's just give them slightly different launch speeds. This is kind of like what we did earlier. We were doing them in succession. Now we're running them together at the same time. I feel like blue is a little hard to see against the background there, so let's make it red instead. There we go. That's much more visible. So now I can see two of these things launching at once. And you notice it's going to stop as soon as one of them reaches 0, as soon as one of them hits the floor. Now, I mentioned that we're animating each of them, so within each loop, I'm animating ball 1 and animating ball 2. Watch what happens when I comment out one of these. I'm now only animating ball 1, the green one. If I reverse that, I'll only animate ball 2, the red one. So it's kind of cool how I can control them each individually, but I'm doing the same thing, right? Because the physics is the same, right? These two balls experience the exact same physics, right? They both determine their acceleration the same way. They both determine their velocity the same way. They both determine their position the same way. And so all I need is to give them something that's a little bit different here, right? So let's see what happens if we try to get these two to collide. So the way we might do that would be, let's start with one of them over on the right-hand side instead of on the left-hand side. Well, now obviously those two are not going to collide because they're going in different directions. So maybe I take ball 1 and I change its launch angle, right? Let's say I change its launch angle. Let's see, if it's originally going that way and I want it to rotate around this way, then I need to give it a launch angle that is greater than 90 degrees. So let's change that launch angle to 100, let's say. Oh, bother, what happened now? I just realized that I did not convert these angles into radians. Which would explain why it was not behaving the way I thought it would. Radians, 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 radians. There we go. That's better. Let's try that now. So yeah, with these launch conditions, these two are obviously never going to collide with each other because they're going in the same direction, right? I need them to go the opposite direction. So let's take launch angle 2 and rotate it around to past 90. Let's make it go just to 100 there. Except that is not number 2 there. That is number 1, of course. We never make these things simple for ourselves, do we? There we go. And so here, I'm not getting a collision because this one hits the ground beforehand. So I guess I need to make greens a little bit shallower, which means going closer to 180, farther away from 90. Okay, almost. Maybe if I increase greens launch speed just a little bit, maybe make that a 12. Almost. Make it a 14. Okay, we're getting close. I need to, let's see, if I make red go up, just maybe up. No, I need red to be a little bit slower. I need red to be just a tad slower. Ooh, and I got them there. I got them to collide there. Now, again, it would be cool if we could get the computer to tell us when they have collided, right? Well, how do I do that? Well, I need to compare their two positions. So let's set up another logical variable here. Collided equals false. This is have the two projectiles collided, question mark. They obviously start out not having collided, so we start out with collided equal to false. And now let's check for did they collide. And the way we do this is just to look at that separation between them. So let's call this separation going to be magnitude of, what did I call them, ball 1 and ball 2. So we just take their two position vectors, subtract those, and that's the displacement between the two, or the separation between the two. And so I'm now looking at the magnitude of that. And so now let's take a look at if separation, we obviously want it to be small, but how small should we make it? Well, they collide if their edges touch, right? So think about this current scenario on the screen. We know these two have collided because their edges touch. So if I think about the position of this one in the center here and the position of this one at the center here, I need those positions to be separated by less than the radii of the two projectiles. So let's say ball 1 dot radius plus ball 2 dot radius. In that case, they have collided. All right, let's try that scenario again. We should get a print of a collision. So let's do banners, collision, collision, collision. And then we'll say while not collided. There we go. All right, let's see if we get a collision here. And there, lo and behold, we did get a collision. You notice we get the collision just as they start to bop each other there. And of course, if we were to code in the actual collision, we would need some information about momentum, kinetic energy, etc. They would just go rebounding off of each other right there. And let's have this thing say, if not collided, then print no collision. Not going to put a frowny face on this one because maybe you don't want a collision. Maybe these are automobiles. I mean, I hope you don't drive your automobile like that in a parabola, but, you know. And so what you can do now, you can, ask students to say, how many winning combinations can you come up with where there's a collision? Or you give a launch speed and launch angle for one and a starting position for the other, and you say, what changes do you need to make in order to get a collision in this scenario?